All right, welcome back. Let's graph some more, today's lesson is called Translations of Functions. And if you remember from geometry class, translate means to slide. So we're basically going to take our basic functions that we talked about in the last lesson and start moving them around a little bit, moving them up and down, left and right. That's it. It's a pretty quick, easy, simple lesson. I think you guys will be real successful with it. So here we go. So let's start with this one. So the first thing I want to notice here, it says graph this function right here, y equals, and then we got absolute values. And so from the last lesson, the first thing we need to realize is this is a V shape. We already know. Before we even start graphing, we know this whole thing is going to be a V. But instead of it just being this part right here, I'm just putting a -3 on the end. And so I can tell you what that's going to be, or let's just do it for the first one, okay? So let's go like this. I'm going to make a table again. Why not, right? You can always make a table. And let's put in, let's just go with our standard. -2, -1, 0, 1, 2. I think I'm going to do these in my head, so follow along with me here. If I take -2 and I plug it in for x, I take the absolute value, it becomes +2. So this becomes, that going in there makes this part +2, and 2 minus 3 is -1. Next one, if I put a -1 into here, the absolute value of that will be 1, and 1 minus 3 is -2. We can see 0 minus 3 is going to be -3. And then notice if I put a 1 in there, absolute value of 1 is still 1 again. It's just like when I put the -1 in there, it turns to a 1. -1 turns to a 1, +1 turns to a 1. So we're back to 1 minus 3, which is -2 again. And the last one, of course, if I put a 2 in here, 2 minus 3, -1. So on this first one, maybe a couple, I'm going to go slow and just plot points again, but that's not the idea of this lesson. The idea of this lesson is to go faster and learn the patterns. But let's learn the pattern right now. Here we go. We've got -2, -1, which is right there. We've got -1, -2, which is right there. We've got 0, -3. Then we've got 1, -2. And then we've got 2, -1. That's these 5 points over here plotted right here. I told you it was going to be a V because it's got absolute value in it. That's always a V. Notice what the -3 did. That's what all we're trying to learn right now is notice what that -3 did. It took the whole graph and dropped it down 3. So the translation on this graph was to shift down 3. That's it. So, there's a couple things we're learning here. We're learning that, yeah, we could sit here and plot points, or as long as we know that this is already a V with a little slope of 1, meaning, see how as I make this V, it goes up 1 over 1, up 1 over 1, then really all I had to do instead of this is just go down 3, know that that's the vertex of my V, or the pointy part of my V, and then I just go up 1 over 1, up 1 over 1, and draw a V. Let's do it again. Next one's going to be the same concept. I am going to go ahead and go a little faster on this one and show you that all you really need to do here, I don't want green. All you need to do, draw your graph. You look at absolute value. You know that the shape of absolute value is a V, but when it was -3, we went down 3. When it's on the outside of the absolute value +4, then we're going to go up 4. So we just go 1, 2, 3, 4. We put a point there. That becomes the vertex of the new graph. And then to be a little more detailed, we're going to go up 1 over 1 and then we're going to go up 1 over 1 the other way to make our v. We don't need any more points than that. It's a v. It's just 2 lines basically. So there's one line, there's the other line, and we're done. All right, let's change it up a little bit. What if the number that we want to add into the function is inside of the absolute value? Before we had the number on the outside, plus 3, minus 3, whatever. Now it's a plus 3 inside of the actual absolute value. So I'm going to go back to a table for this one for the first time just to show you what's happening here. And I'll go ahead and start again with the standard. I might have to add some more numbers to this one. We'll see. All right, so let's do it in our head again. We got this time when we take -2, plug it in, it's -2 plus 3 inside of here, which is 1. Here, let me do it for you. So it's -2 plus 3. That means y would equal absolute value of 1, but the absolute value of 1 is 1. So this is a 1. Okay, that's what we're doing. I'm not going to plug them in every time like that, but I just wanted to show you that I'm taking this number, putting it in there, doing what's inside of here first, and then finishing by saying absolute value of that number. Next one's going to be a 2. Next one's going to be a 3. Next one's going to be a 4. Next one's going to be a 5. And here's the deal. We know that absolute value is a V shape, but we're not going to see the V shape if the numbers don't change directions at all. If it just keeps going up like that, we don't get the V. So what we need to do is try some more points. And obviously going bigger here isn't going to help, because the bigger number I go, the bigger number there'll be in here. It's just going to keep going up. I needed to start, actually, instead of starting at -2, I probably should start at -3, -4. So let's put those points in there. So you can see that if you plug a -3 in there, you get 0. And the absolute value of 0 is 0. If you put a -4 in there, -4 plus 3 is -1, but the absolute value of -1 is 1. And we did it. We ended up getting the same y value twice. So let's make a graph. Let's see what we got here. We've got too many points. We don't really need all this stuff. I just wanted to show you how this all works. -2, 1. It's right there. -1, 2. It's right here. 0, 3 is right here. 1, 4 is right here. 2, 5. I'm gonna, we could draw that, but we get the idea. But then these bottom 2 points, -3, 0 is right here, and then -4, 1. And there you go. Now you got your story has been told. There's the V. Of course, it'll keep going on this way too. It's going to look like an actual V if we had more room. All right, that was not the important part. That was just a one-time deal to show you that I physically put the X values in, got the Y values, plotted, and look at what I want you to do now is look at this graph and look at this equation. Notice that when you have a +3 inside of the function, it actually does the opposite of what you might think. It does not move the function to the right, even though there's a plus there. It moves it to the left. It does the opposite of what you'd think. Why? Well, because it did, right? We plugged all the numbers in, and that's just the way it works out. By plugging all those numbers in to this function, it created these y values. When I plotted them, the graph had moved to the left 3. So when something's inside of the function and it's a plus, it actually moves it to the left. If you remember from the last 2 problems, when it's outside of the function that we're adding a number or subtracting, it moves the function up and down. When there's a number inside the function, so far we know if it's plus, it moves it to the left. Well, let's see what happens on the next one. So what if I put a minus inside of the function? going to move it to the right. So all you really need to do is go to the right 2, put your vertex there, and then you know it's a v because it's absolute value. And so you just, and the number in front of here is still 1. That's kind of like your slope. So it's still just going to be up 1 over 1, and then up 1 over 1 like this. And that's how we really want to start thinking about these functions. If we know all the basic functions, and then we start messing around with the basic function by putting numbers here, eventually we're going to put numbers in the front and in here, all that. We really just have to move things around. We don't always have to sit here and do this. I mean, this always works, and I love it, but I also like doing things quickly, especially when I have a whole bunch of them to do. So what if, here's the next one, what if both things are going on, right? So we got a number inside of here, and we got a number outside here. All right, so this is where you want to really start getting this straight, okay? Before we even start graphing, this 3 moves the thing up 3. Remember, the outside number, it's the up and down amount of the graph, and it's normal. If it's plus, it goes up. If it's minus, it would go down. That seems like it makes sense. The inside number moves the graph left to right, and it's the opposite of normal. So when it's minus, it actually moves it to the right. When it's plus, it actually moves it to the left. So this is going to be right 1, up 3. So why not just do that, right? So we're going to go to the right 1 and up 3, and we're going to put our vertex right there. That's really what we're saying here, is that it's shifting the pointy part, or the vertex of the function. It's the vertex that's moving, which is that spot right there. Okay. But we still have our slope of up 1 over 1, so we just go up 1 over 1, put a point there, go up 1 over 1, put a point right there, and we have our new graph. Didn't need to plot points. I knew that the graph was going to shift to the right 1, up 3. That would be the new vertex, and then I just draw my V. I know it's a V because of absolute value. One more. Same almost idea, okay? Almost the same idea. Only this one, and there's a few more of these on. There's only absolute value, and then there's quadratic or parabolas, U shapes. Remember, anytime a function's squared, it's a U or a parabola. So this is just now the same kind of shifting, only instead of drawing a V, we're going to draw a parabola or a U shape. So same idea. Let's go ahead and start the graph. It's going to be left 2 and down 1. Once again, the number inside of the function, or inside, in this case the parentheses, that number moves it right to left, right and left. And if it's plus, it's the opposite of what you would think. You would have thought it would go to the right, but it actually goes to the left too. The number on the outside moves it up and down, and if it's normal. So if it's negative, it goes down, just like you might think. Okay. So we're going to go to the left 2, and we're going to go down 1. And that's going to be the vertex of this graph. But it's not a V. Remember, it's a squared equation now. It's not the absolute value. It's squared. It's going to be a parabola. So on these, we have to be careful. We don't want to be too lazy and just draw some random U. When we did our V's, we knew that it was up 1 over 1, so we were still drawing a very accurate V. But I don't want it to be some just casual U. We don't remember, what if it's this? What if it looks like this? So we still want to plot a few points on these. When they're parabolas, squared equations, we're going to want to make a table still. But at least we know we have our starting point. And that is important because now I know what points I'm going to put in here. There's no guessing. I want to put in at least 2 points to this side of the vertex and 2 points to this side. So I'm not even going to bother with points over here because this thing's already moved this way. So I'm going to do -4, -3. And then I'm going to do -1 and 0. See how much easier it is if you know where that vertex is? You don't have to sit here and just make up random numbers. You pick the ones that are, look at 2 over here to this side and then 2 right here. But we still got to do the math. So we're going to take -4, we're going to plug it in here, do the math, and get the answer. I'm going to do it in my head. I'm going to go slow. I'm going to say it. Here we go. -4 plus 2 is -2. But when you square it, it becomes +4 because -2 times -2 is 4. And 4 minus 1 is 3. Do it again. -3 plus 2 is -1. But -1 times -1, because it's squared, -1 times -1 is 1. 1 minus 1, 0. Now, this is where it gets extra easy, because look, -1 plus 2 is 1. 1 times 1 is 1. 1 minus 1 is 0. We're going to get the same values. There's going to be a symmetry here between these. This and this go together, and these are going to go together because it's a parabola. We'll see that in the picture here in a second. The last one, of course, we're just taking 0 plus 2 is 2. 2 squared is 4. 4 minus 1, 3. Just like that. 3, 3. And we have -4, 3, which would be this point right here. We have -3, 0, which would be here. And then we have -1, 0, and then we have 0, 3. And remember, since it's a parabola, it has like a line of symmetry down the middle. You don't need to draw this, but I'm just showing you that if you go through the trouble to find the point over here, and you know this is the vertex, so you know this line kind of slices it in half, then there must be a point right over here on the other side. So if you go 2 to the left and up 3 here, then you're going to go 2 to the right and up 3 over here. It's not slope because it's curvy, it's not a line, but it has a definite relationship going here. Same thing here. This is the middle of it, so when I went to the left one, it was right there, so if I go to the right one, it's going to be right there too. So some of this might be a waste. You might just need a couple of points here, plot them, and then you can just flip them over to the other side if you're trying to save yourself, 20 seconds or whatever. I'm going to stop there. You'll find out that is more than enough to get you started on the lesson. That might even be enough to do everything. So hope that helps. Work hard. Be nice. See you soon.